Model your domain, derive the rest. There's no better way to describe Ash, an Elixir backend framework that works great both with Phoenix Live View and to create APIs of all kinds. Let's dive in. The central concept in Ash is the concept of resources. Things like posts or comments in the case of a blog. A resource can have attributes like title or content. The attributes can have various types. For example, for status, we can use an atom. Ash also gives us some helpers like a UID primary key or timestamps to add inserted at and updated at fields and set them for us automatically. We can also add constraints. For example, we may want the title to not be nil or the status to always be one of the specified values. Let's also set the default one. Resources can have relationships to other resources. A post can have many comments, and it can belong to the user that created it. Again, we can add some constraints or even specify additional behavior when loading a related resource, like sort order in this case. How do we create or change an instance of a resource? We use actions. Like in typical CRUD, we have create, read, update, and destroy. In simple cases, we can just use the default implementations, like for read or destroy here. But to define a custom action, we specify its type and name. By convention, we often call the primary action of a given type the same as the type itself. Now, let's specify the attributes that it accepts. When creating the post, we only need title and content. Other params will be set automatically. For the update action, we'll also accept status. We can have multiple actions of a given type. Let's say we want a customized read action for getting all the published posts in the right order. We filter posts by status, and finally, we can use so-called preparation to specify the default sorting order. A preparation is performed before a read action to prepare the query. Just like preparations for read actions, we have changes for create, update, or destroy. Many predefined changes are available out of the box. We can use relate actor change to relate the provided user to the resource and keep its reference in the created by attribute. Notice that we're not writing any imperative code. We're just modeling our domain, and Ash will derive implementation for us. Now let's introduce the concept of a domain. A domain groups related resources together and defines centralized code interface to access them. I've already added the command resource to our blog domain, but let's add our posts too. We also need to set it on the other side. Now we define the actions that will be available publicly. We'll just mirror our resource actions with some meaningful names. But we can also extend the behavior of actions here. Let's say we want to get post by ID. We can use the get by option and specify that we're searching by ID. We haven't touched a data layer so far, so all of this is independent of the database. But most often we need some data layer, so we'll use PostgreSQL in our case. For that, I use one of the mixed tasks from Ash instead of writing everything manually. You can see the data layer here and this PostgreSQL section. Here is the table name and the Ecto repo that Ash will use underneath. We'll do the same for our comments, but here we will also want to specify how our foreign key index will be generated. Also, when deleting the post, all of its comments should also be deleted. As you can see, we're nicely encapsulating database-specific parts in the PostgreSQL section. Now, let's talk about controlling access to our resources. We can use the policy authorizer for that. Again, we can add it to our resources using the mixed task. After that, we can specify policies. Let's say we have a given action type, like create, and we want only logged in users to create posts. We will use the actor present helper here. For update or destroy, on the other hand, we only want the author of the post to be able to perform those actions. So now we authorize only if the created by ID is equal to the actor ID. Finally, to read our posts, we should either be the author or the status of the post must be published. For comments, on the other hand, I want anyone to be able to create them, but the post has to be published for that. Notice that we can use relationships here. And finally, for the read action, we allow reading comments from published posts, or if you are the author of the post. While we're here, let's also talk about access to attributes. By default, most attributes are not exposed to external interfaces like JSON API or Phoenix Forms. To make them available there, we can use public true. For the post, we want all the attributes to be available, so title is public, content is public, status is public, and finally the timestamps. ID is public by default. I already did the same for comments. Summarizing this part, we created two resources, post and comment. They are grouped into the block domain, which also defines a code interface for those resources. In each resource, we defined attributes with constraints, relationships with other resources, actions that can be performed, policies restricting access to those actions, and a data layer to store and retrieve them from the PostgreSQL database. Now to the fun part. Let's start with code generation. There is a command mix-codegen that basically generates all code that needs to be generated. That includes database migrations, but also any other stuff that can be added by extensions. For example, TypeScript interface that we'll see later. Now, we just need to run the migration and our app is ready to use. I've also added some random data to the DB so we can see the app working. But not all code needs to be generated. The code interface derived from our domain is available right away. I can use this code interface to read all posts that are available to a given user. Results only include published posts and the ones created by that user. This confirms that our policies are already intact. Now, when we create a post and provide our actor, we'll see that the post gets created as a draft, so it should be accessible only to its author. If we try to retrieve this post as another user, we get a not found error. As for read actions, unauthorized records are filtered out by default. There are also some helpful functions checking if given action can be performed by the user. For example, we can check if a user can destroy a record and decide if we should display the delete button in the app interface. But now let's quickly go through a few more specific integrations that Ash provides. Here I have a live view page generated by AshPhoenix generator. As you can see, AshPhoenix gives us a few helpful functions to use with Phoenix Forms. We have helpers to prepare, create or update forms, a function to validate the form, and a function to submit it. It handles the important cases of connecting Phoenix Forms with Ash validation for us. Now we can try JSON API. Again, mix-ash extend task can help us with initial configuration. Then we need to define a type name for each resource in the API. It's also similar to the code interface. We explicitly specify which actions should be available. We can also specify the related JSON resource. We just need to make sure that our relationship is public, similar to attributes before. And that's enough to get our API up and running, including Swagger docs and the OpenAPI specification. Similar case for GraphQL. We specify a type name and explicitly define queries and mutations. That gives us GraphQL up and running with all the types and stuff. Now we can also have TypeScript definitions to use our API easily with frameworks like React. Again, we're simply defining which actions are available and what their names will be in this particular interface. To make it work, we also need to define the type name. Now we need to use mix-codegen again, similar to how we used it with migrations. This time it will generate our TypeScript definitions that we can import and use. And we get all the types, relationships, and so on. Finally, let's wrap it up with AI. We'll define tools that will be available to our agent, like getPost. This time we need to provide a relevant description to be used by an LLM. What's important is that Ash policies also apply to the tools, so our agent can only perform actions that are allowed to the provided user. I used Ash AI generator to create example chat view here, and now we can see it making the tool calls and giving an answer. There are no comments for those posts, so let's ask. And here we have it. Model your domain, derive the rest. That's the core idea behind Ash. As we saw here, defining actions, authorization policies, attributes, relationships, and other stuff inside our resources lets us reuse the same data structure and behavior in various places and APIs, saving time and avoiding subtle bugs. And what I showed you here isn't everything. Ash ecosystem makes our life easier in many more areas. And if you want to dive deeper into learning Ash, I can't think of a better resource than the Ash Framework book. It has an easy-to-follow tutorial form and lets you quickly get up to speed while learning the nuances directly from the creators of the framework. And that's it. That was Ash Framework in 11 minutes. See you in the next one.